Hey guys, we on Trigonometry Revision GCSE. Here is the problem 2 and we're going to consider 3D problem solving. Just remember in the previous video we accomplished problem number 1. That was pretty basic problem and standard for all standard GCSE papers that not higher tier. So here is a bit more complicated problem. Make sure you're be able to accomplish problem as we considered in the first part, and here we go doing that. So here is the cuboid. So cuboid is basically a stretched cube in one direction, so that now it doesn't have equal sides, but obviously the base is going to be a rectangle, definitely. Okay, so here is cuboid with two diagonals km and mn. Okay, we have marked as red two diagonals on each face. So find the lengths of each diagonal. All right, so what we're given, I set up new point. Let's take new point L, and we know that KL is 20 centimeters. Okay, so how to figure out diagonals? You need to consider two right angles triangles. So the first triangle is KML, is a right angled triangle. And because actually for cuboid we have ML as the height to the base. So the base is the bottom part. Alright, so it's right angle as well as triangle M and L. So triangle M and L also. But first, let's consider diagonal KM. In this case, diagonal is going to be a hypotenuse, right? If you consider triangle, so KM is hypotenuse, you have angle 35 degrees and you have 20 centimeters as adjacent side to the angle because it's the part of the angle, basically its arm. Okay, so we applied trigonometry and trigonometric ratio that connects adjacent side and height. So you just remember that adjacent side by definition is height times cos of the angle theta, right? In our case, what we have 20 centimeters adjacent side is equal to km, which is unknown, it's height, and times cos 35. Okay, we've got that, from where we can calculate km is simply 20 over and cos 35. Right now we are going to calculate that. So km in this case is going to be, let's calculate, so 20 over cos 35. And we've got 24 something, so 24.42 centimeters to 2 decimal place. So we figure out one diagonal. All right, it's good. So let's go on. So the second triangle M and L. Okay, let's consider triangle M and L is going to be also right angled. Okay, right angled. So we are going to consider MN as diagonal. So in this case, diagonal, that's the height. So, and we have 25 degrees as the angle. But unfortunately, we don't know any of the sides. Okay, and we don't know height as it is. So before doing that, we need to find one side. For me, it's easy to find ML. So let's find ML first. So ML can be found from triangle KML. So ML is going to be the opposite side. So that side is going to be opposite. And from where you can say that ML is going to be height, again height, which already we found. So it's KM times, let's say, sine of 35. That's the first way. So you found that, but I don't recommend set up equality or equations that involves previous value that you calculated. Because right now you can use also tangent. So alternative way to that is to use ML to adjacent side, which is 20, or let's say SKL, that's going to be adjacent side, and that's going to be tangent of 35. In this case, KM is not involved, so you're already working with known variables, and those variables already given to you. They're not variables itself, so you're working with knowns. So from where you can figure out more easily and more accurate. Okay, so let's take it. ML is going to be KL times tangent 35. So from where you can say that KL is 20 and you multiply by 10 of 35 degrees. From where you can figure out ML. So let's take ML and say it's 20 times tangent of 35. So according to my calculation, it's going to be 14 to 2 decimal place, so 14 centimeters. So we figure out ML, and right now what we can do, we can use triangle M and L. So from the triangle M and L, we can work out the value for height, which is MN. So how to figure out MN? It's simply that side which is hypotenuse, this angle, and we can use ML that we recently calculated. So I highlight that here we've already calculated ML. ML is here, is tangent 35 times 20. We've got 14 centimeters, and now we are going to work out height. Okay, so first let's complete the equation. So that side in the triangle M and L is going to be adjacent side to that angle, which is 25. So that's why we can use ML is MN times cos 25 now. Cos, and here I'm going to use 25 degrees. Okay, it's going to be cos 25 degrees. Okay, so from where we can figure out MN value, and MN value is simply ML over cos 25 degrees. From where we can plug the value ML, which is 14 centimeters, so we plug it here, and we've got 14 over cos 25. Right now we're going to use calculators, and finally we'll get MN as, let's go and do it, so over cos 25. Okay, I've got 15.45 centimeters to 2 dp, okay, 2 decimal place. All right, we've calculated all the diagonals, that one and here, so we actually found all the diagonals. So that's the length. All right, how to check yourself whether you're correct or not. So just simply the first testing tool is just to make sure that KM that you found, 24.42, is actually more than 20. So KM is the longest side in the triangle KML. So it's actually works. It's more than 20. So for the triangle MNL, so we found MN is 15.45, and again should be more than any of the sides. So if you compare with side ML, in this case it's 14 centimeters, it's definitely more. Okay, so your testing tool works correctly. All right, that was the second problem for 3D problem solving using trigonometry. Hope you enjoyed, and up to the next problem 3. See you later.